Right, good afternoon, everyone, and welcome to our CAWASA Wednesday webinar. This is our webinar number 7, and today we have a special guest out of Michigan, and he is Mr. Casey Fiedler. He sits on the board of the Wastewater Education and Michigan Septic Trade Association. He's a certified time-sale septic inspector on-site systems in Michigan and operates a fully integrated on-site septic company in Michigan, performing design, installation, operations, and maintenance services for septic systems. Today he'll be taking a look at tips and tricks for locating on-site wastewater system components. He'll also talk to us about the tools, methods, and common mistakes. And while he is from North America, hopefully some of the tips and topics can help on-site wastewater technicians from any area who can also, he says, learn from his mistakes. So I don't know that Valerie can join us today because she's traveling through the Caribbean on mission. But I'm Ignatius Jean, the Executive Director at the Caribbean Water and Sewage Association. And I'd like to give the floor to our guest today, Mr. Casey Fiedler. Welcome, Casey.
Thanks. That was a nice introduction. I appreciate that. Hey, everybody. So kind of wrap that up. I got started in the wastewater business. My folks ran a septic pumping company when I grew up. I used to get paid to go pick rocks out of the field because they would do land application of septic waste. When I was a kid, if I wanted money, I would go pick up rocks out of the field that would get stuck in the equipment. And that's what I would spend my weekends doing if I wanted to make some money. So I kind of grew up in the business on the pumping side of things. And then when I got a little bit older, ended up taking over more of the business and going into inspections and all that sort of stuff. So this is going to all be on-site stuff. A lot of it is specific to our areas. We were just talking about some of the things like we were talking about constructed wetlands. I have never even seen one in person. I know they exist. I'm familiar with them. Don't use them around here. I have never had the opportunity to actually get my hands on one. So very aware that some of this may be regional and hopefully some of it will apply to all of you. I think from what I understand, I think there's a pretty broad group here as far as on-site and decentralized and centralized operators. So hopefully y'all can get some information out of this. I've given this presentation a handful of times. But yeah, I mean, even in North America, from East Coast to West Coast, and Canada, the US to Mexico, there's, whether you're in the desert Southwest or Caribbean or, here in Michigan, just very wildly different applications of on-site systems and what's common and what's not common and how things are used. So whether this is directly applicable immediately or not, hopefully at some point you find yourself able to use some of these thoughts, tips, tricks, suggestions, all that stuff. So at this point, we do everything from design and install to my specialty is inspections and kind of the technical side of operations. So in my experience, it tends to be certain types of final treatment areas that go missing. So we're talking about drain fields for on-site or decentralized systems here. In our area, it's very uncommon to have a subsurface like centralized system, so like a large system that's going to a drain field. Sometimes we have like mobile home parks where you have 30, 40, 60 dwellings hooked up to a decentralized system, and some of those go to big subsurface systems. But anyways, so more modern systems, newer systems tend not to go missing as much because we have better record keeping. Systems that have been installed since computerized records, digitized records have been more commonplace, and people are actually requiring permits more now, where things used to kind of go under the radar. Things tend not to go missing as much anymore, which is a good thing. So systems installed prior to good record keeping are the ones that tend to be the most difficult to locate. A lot of the modern systems, obviously, like raised systems or any systems that might feature advanced or alternative engineering, tend to have really good records, or they can be really, really obvious. Where, if it's a above native grade system, such as like a mound or a sand bed, sand filter, that type of stuff tends to have apparatuses that you're going to see pretty easily. It's pretty self-evident. So midnight specials, if that's language that you're not familiar with, it's what we call somebody's weekend installation. They never got a permit and they went out and installed it at nighttime and nobody could see them put it in. So if there was never a permit pulled, might be hard to find it. Building additions, whether they added a whole nother building, like a outbuilding, like a pole building or something, and it has a bathroom. Um, in our area, it's more and more common for people to build into a pole barn or a pole building to build in a living space. So an old barn or a barn that was existing, they might build a living space in there that's for parties or for a guest house, and then they could add a system onto that nobody knows about, or they could build a shed or a garage right over the top of an existing system, which I've seen several times. Y'all are on mute, otherwise I would ask you how many of you have seen a system um, with a structure built over the top of it, but I've run into it several times. Or driveway, asphalt driveway or concrete driveway built over an existing system, that happens. And houses or structures with no final treatment area whatsoever. Um, I usually run into about half a dozen of those every year. Either it goes to a farm tile. So in our area, again, um, I don't know your area very well, but in our area, oh geez, I mean, from the early 1900s into the mid 1900s, it was very common for drainage work to be done where they would tile fields that were wet or swampy. And those tiles would take the water down to runoff areas. And so systems tied into those runoffs are still very common. So the systems that get lost tend to be dry wells, seepage pits, conventional bed or trench systems that are in grade. Um, and more modern systems tend not to. Bed systems, even though they do get lost, tend to be easier to find. There's just more to hit. How do tanks go missing? I've run into this several times where the homeowner passed away and nobody knows where it is, especially if it's an older home and there's no records on file. And the homeowner happened to be the only person that knows where it was, especially if the homeowner was the one that built it or installed it. The other thing that happens sometimes is new property owners move in, they've been living there for 10 years, all of a sudden they have a backup, there's a problem, nobody knows where the septic system is, and then all of a sudden everybody realizes that, well, 10 years ago, the last person that knew where it was passed away, and now no one knows where it is anymore. And again, homemade tanks or non-permitted stuff that has kind of gotten reclaimed by native vegetation. So you'll get, systems that nobody maintained, and now the drain field hasn't been mowed in 10 years, and it's basically gone back to being the woods or the forest. All right, so we're going to talk about tools for locating. Number one is the probe. Um, Up here, there's a company that called TNT that makes good probes. They're actually out of my home state in Michigan. I don't know if those around here, that's basically the only probe that anybody uses, but I'm sure in other parts of the world that's probably not the case. But I tend to go with a thicker probe because of the thinner probe. So there's like I kind of screenshotted this. I use the 7/16, which is a pretty thick, beefy probe. The downside is it's so thick that it can be hard to get in the ground, especially probably not the case in your area, but up here in the fall, it gets really dry. It can be really hard to get the probe through the ground. So anyways, I do 48 inch and I use the ball nose. We're going to talk about that in a minute. Ball nose versus the pointy nose, the standard pointy nose tip. I was doing an inspection one time and I was going along. This is when I was newer. I don't know about you guys, but I made plenty of mistakes the hard way when I got started. Turns out, nobody tells you a lot about figuring all this stuff out and spoon feeds it to you. But I was going along probing and I kept hitting something that was kind of bouncy and it kept giving. And I was like, I don't know, for some reason at the time I thought maybe it was a root or something. Anyways, pro tip, if you haven't already figured this out, if you're probing and there's something bouncy under the ground, stop probing because it's probably a pipe. In that case, it was a water supply line, and I turned around and looked behind me, and all of my probe holes had water shooting out of them. Anyways, needless to say, I was on the hook for that repair, and that wasn't very fun. So from that, that's why I use the ball nose. It can still do damage, but it does a little less damage, a little bit more forgiving. I use the slide hammer up here. Again, ground can get really, really dry and hard. The slide hammer allows you to use the handle of the probe as a slide hammer if you're not familiar with that tool. It's an awesome tool. TNT, again, is the company that makes these. If you don't have one or they don't exist down there, I'm sure you could order one. It's a great tool. They make them in a couple different weights. I use the lightest weight possible. The more weight you slide hammer with, the more likely you are to do damage, or it can be hard to feel or get feedback on the probe. If you've got the slide hammer and you're just hammering away into the ground, you can't really feel what's under the probe, which again, I don't know how much probing y'all do for locating, but I do a ton of it for locating final treatment areas, and being able to feel and hear the texture of the soil that you're going through on the probe is really helpful. Because again, we're looking for gravel, right? We're going to be looking for trench gravel or bed gravel, usually some kind of aggregate. And when you get into that, I mean, it's like walking down a gravel road or gravel driveway. You can hear that crunch. You can hear it on the probe too. You can hear that crunch, and you know you're in the gravel. Again, be careful not to hammer your probe through system components. I don't know how common, I call them poly tanks, but plastic, fiberglass, synthetic tanks, or poly, like chambers. So like the infiltrator quick chambers or other types of chamber systems that are like a molded plastic. You'll hammer right through those. Um, Again, if you've never probed through a chamber unit, you will eventually. It will happen. You're not going to destroy it. Try not to do it, but it happens. It sucks because the probe tip goes through the plastic, and then the plastic tries to close around the end of the probe, and it's almost impossible to get the probe back out of the ground, which is where the reverse slide hammer comes in handy. So if you put your probe through an infiltrator chamber, good luck getting it back out. Not that I've ever done that. Probing in the winter. I don't think this is going to apply to y'all, but I'll share it with you anyways, because I'm sure you'll get a chuckle out of it. Up here, when it gets cold enough, we have frozen soils on the top layer, and I use a impact driver. This is actually a picture of mine on the back of my truck. I use like an extended bit for drilling through wood. Obviously, it gets dull really fast because I'm drilling into soil, but it still works to move the soil. And it's just a little bit bigger than the tip of the probe, so I'll drill through the frozen layer of soil and then probe from there. So if any of you all ever end up probing for septic systems in the Arctic or in Michigan or wherever, little pro tip for you, take your auger with you. All right, sweet. So other tools, we're looking at cameras and sondes and locators. There's some pros and cons with these. I have kind of reverted to very simple use of them. There's really fancy cameras and locators, and then there's really simple ones like analog versus digital, and how much information the tools are going to, how much work the tools are going to do for you versus how much you're going to have to do yourself. So on the upside, accurate and verifiable. I always like to have verifiable information. I'd like to avoid subjective information as much as possible. Obviously, that's, if you're inspecting a system, that's your goal, is to be objective and not, subjective with your reporting. The other upside for a camera is that you can actually see what's down there while you're running the camera. So that can be handy. And it can be a lot faster than probing. Downsides, though, the tools are expensive up front. Purchasing the actual tool itself, I mean, I think the first camera I ever bought was like $800, and that was quite a few years ago. I'm sure they're not that cheap anymore. And I would never buy an $800 camera again because it was a piece of garbage. And that's US dollars, so I have no idea how that translates. But suffice it to say that if I bought a camera again, I would buy a more expensive one because I basically wasted my money the first time. So they're not cheap to get started with. They can be time consuming, and it can be difficult to access to get the camera into the pipe where you're trying to go, depending on the setup. It's not always easy to do. And of course, because of the extra cost of the actual equipment, right? A probe is $100 versus a camera that's thousands of dollars. That cost has to be passed on. If you're doing municipal work or industrial commercial work, the customers may not care that much. If you're doing residential work and the customers don't have a lot of money, those costs add up pretty quickly, especially when somebody's already having, if you have a client that's doesn't have a lot of money and they're already having problems, the bills are going to add up quickly. So that does suck. Unfortunately, not a lot of ways around that sometimes. Depending on, so we're talking about mostly for residential and small commercial, you're going to be from the source down the outlet pipe to the tank, into the tank, and then out of the tank to your final treatment area, right? So depending on whether we're locating the tank or if we're locating the final treatment area, we need access to that pipe to get either a flushable locator or a camera and a sonde locator down that line. So if you don't have a clean out, like in Michigan where I'm at, most people have a basement. So you go down in the basement and there's a 4-inch pipe leaving the side of the wall, usually, and that pipe has a clean out on it, usually. Sometimes if they're old enough and it's cast iron, you can't even get the cast iron clean out apart. You may have to go outside and start digging up the line and actually cut into the line. So you may get into some serious work. It's not always just a given that we're going to have access to run the camera. Or if the system is actively backing up, you can't pull the clean out in the house because you're going to make a mess in the house. And if there's no outside clean out, now you're digging outside, find the main line, cut the main line, make a mess, run the camera, put the main line back together, install an outside clean out, all sorts of stuff. So um, they're not always a perfect solution. They work great if you already have access to the pipe that you're trying to run the camera down, but it's not always a winner. You may need to have the tank pumped down if you've got a tank that's backing up and is above normal operating level. You have to pump that tank down in order to get the camera out the outlet line. Depending on what kind of outlet device you have in there, if you've got a filter, you can pull the filter out. Usually you can just go right out the outlet basket. But if you've got an old like a 90 elbow as an outlet device, you may have to cut that off and then run the camera and then reassemble the outlet device. So that's always fun. Um, Other alternatives to locating. So we have some kind of pseudoscientific alternatives to locating. Some people use witching or dowsing. Um, Again, if it works for you, great. If it doesn't work for you, like I can't do it, it doesn't work for me, it's completely useless. If it does work for you, just make sure that you still objectively verify. I've been in a few situations where somebody used dowsing or witching to locate things, and then they literally said to the customer, like, "Oh yeah, your drain field's here, this line, and your septic tank," and then they just left, and I got on site, and it turned out none of it was true. The septic tank was not actually where they thought it was, and the customer ended up just being very confused because someone was basically walking around the yard with sticks and making things up. So if you can get it to work, great, but you want to verify that with a probe or a camera or something. Um, I don't know about all y'all, but ground penetrating radar, way too expensive for most applications up here. At best, you're looking at probably $15,000 US to get into ground penetrating radar. Then you need training on it. You need to be able to know how it works. And there's different types, very specific situationally. Very rare. I've never talked to anybody that actually uses GPR, ground penetrating radar, for on-site system inspections or locating. Sometimes for municipal or decentralized, that's kind of where it comes in is bigger systems, but definitely not for your normal residential applications. Way too expensive. Um, New stuff comes out all the time. And if any of you are all using different tools or methods, feel free to throw them in the chat. I always ask if anybody's using some new interesting tools that maybe I haven't heard of or anybody else hasn't heard of. So if you're out there doing work with different tools and I didn't mention them, make sure you let me know. The other thing sometimes people will use is like what am I trying to say? A metal detector. Because at least up here, a lot of the tanks are cast with a metal lid on the inlet and the outlet, along with typically some, remesh or rebar inside the tank for structure as well. But obviously, metal detector is going to pick up anything else in the area that's metal, so that may not be particularly helpful. I got my cat trying to jump on me over here. Okay, so before we even get to the inspection, let's see what we can do. Get some office work done before we head out. So for me, what I do first, both so that my life is easier and so that I don't get something wrong and say something incorrect, I pull the records. Here we go to the county to pull the records. I don't know if your records there are kept at state, city, township, probably not even called that, but find out who has the records in your area for on-site septic systems, and make sure you have access. A lot of times they have digital systems where you can log in and you can just request records. Some places have them publicly available. Around here, we mostly have to request them. I can't just go get them off of a public website. So phone call, sometimes you got to know the right person to call to get the records, but pull your records. Um, on top of making your life easier, so you actually know where things are. Um, if there's any kind of legal problem, so if you go do an inspection and that inspection were to ever get questioned legally, let's say you missed something and you did the inspection and it turns out you totally missed that there was a line with wastewater going straight into the neighbor's creek or pond or something, and it caused a health issue and you end up in court. Hopefully that never happens to any of us, but you would probably want to be able to prove that you did do your due diligence and tried to get as much information as possible, that you did pull the records. I would not want to be in a situation where I was, being legally tested and I couldn't prove that I actually went and tried to get the records, because that kind of sounds like negligence, and we don't want that. Your insurance company will not be happy if you've got gross negligence case. Um, Records save you a ton of time, typically. If any of you haven't run into a case where you have records, but they turn out to be totally wrong, you will. I've had that happen a few times. It's a real pain in the butt. You might have records that were from 30 years ago and somebody did a non-permitted alternative or change something. Usually you can figure that out pretty quickly when you're in the field, but sometimes not so much. So this probably doesn't apply to y'all in your area, but up here, County Department of Environmental Health is what keeps the records usually. From the office, we can use some satellite imagery. We're going to talk about that some more in a second. Google Earth Pro is fantastic. There's a couple reasons for that. We'll talk about it in a minute. There are satellite settings on most map applications, and they allow us oftentimes to look back in time, look at different snapshots like historical satellite imagery. So at least where we're at, and I'm assuming this is probably relatively universally true, especially if you're looking for a trench system or a subsurface system, they're going to be in an area without trees. So if you're going to a site, you can usually preclude areas that are heavily wooded or forested that haven't been cleared. Usually their area is going to have to have been cleared at some point in order to install that on-site system. So you can pretty much rule out those heavily forested areas. So in Google Earth Pro, if you go online and you search Google Earth Pro, you can, we'll circle that, Google Earth Pro. It's a downloaded application on the desktop. You can't do this on your phone, on the Google Maps app. You can't do it on the browser version. You have to download it. If you go to the view menu and then click on historical imagery, it brings up this extra box with this like slide bar on it where you can go, in this case, apparently all the way back to 1930, although I have a strong suspicion that there weren't any satellites in orbit in 1930, but I could be wrong about that. Just kidding. I know I'm not wrong about that. At least I better not be, because that would bring up a lot of weird questions. So in this case, where's the drain field? You can barely see it here. This is the standard view that comes up with the most recent image from this dwelling. And barely you can see the outline of this final treatment area. This is a trench system. You can see it down in this circled area. But if we use the historical imagery, we can see where it's at. If I undo that, I don't know if you were able to see it before I lined it up, but that's what it looks like. And this is like up here, this is, you can see all the trees are the, oh geez, what am I trying to say? The non-evergreen trees, deciduous, there we go. The deciduous trees are all leafless, so this is in the winter. I would expect to find the tank in that area for this residence. If we look at October of 2016 versus July of 2018, same site, much more obvious in this photo from July of 2018, just because conditions and time of the year. If the soil's dry, sometimes the drain field will show up, or the final treatment area drain field, sometimes it'll show up as being more dry than the surrounding area, which is the case here in 2018. It appears more dry. Or sometimes it shows up more green and lush. A lot of times people will use, in the inspection world, lush vegetation over a drain field tends to be a bad thing. If it's really lush and swampy and we have surfacing, right, that's definitely a bad thing. But sometimes it's not necessarily a bad thing, especially in our area when things get drier. The grass just sucks up some of that extra moisture that's coming from the drain field, and it shows up as, the rest of the area might be brown and dry, while the drain field could show up bright green just because it has enough water. So just because it's greener doesn't always mean that it's failing or that there's a problem. I'll give you a second to look at this one, see if you can guess where the drain field is. Again, this one is, you can see the wood lot to the right, that forest is all missing its leaves. So this is a winter picture. Drain field is on the north edge, just at that line where that field is located. So there's a farm field to the north edge of this residence. You can kind of see that right there. And if I was looking for a tank here before I got in the field, I'd be looking, there's a little bright green spot just off the northwest corner of this house, about 10 foot off that edge. That's probably where I'd be looking for that tank. So same location, one picture to the next picture. So this one's, hopefully the image is coming through on Zoom pretty well, but that's, it doesn't get any more obvious than that. I mean, you could literally measure that drain field using the satellite and get like 50 foot here and measure everything about it. You can see it plain as day. All right, so before we grab tools, once we get to the actual inspection site, I try really hard not to get my tools out, leave it in the truck, go talk to the homeowner first and walk the site a little bit. Emperor's New Groove, no touchy, don't touch the tools yet. The reason being, if I pick up my probe and I pick up my measuring wheel and I pick up my soil auger and I just start running around, I end up getting ahead of myself usually. So I try really hard to leave the tools and make at least one circle of the property without any tools in my hand, just to soak it in and look at, where's the structure? What do I see? Do I see anything obvious? Are there risers? Am I already seeing septic tank risers? Do I see, an obvious drain field? Do I see a mound? Do I see a control panel and an alarm? Looking for stink pipes or vent pipes on the roof. I'm looking for open areas, looking for topography, right? If we have a gravity system, it has to go downhill. It can't go uphill. If we don't have a gravity system, maybe we've got a control panel on the side of the house. If I see a control panel on the side of the house, it immediately tells me a bunch of things. Look for changes in topography. So if there's, if you've got a site where there's a steady gradual grade and then all of a sudden that grade flattens out and then starts going again, if you've got a bed or any kind of subsurface final treatment area, that subsurface final treatment area has to be installed flat. Doesn't mean they can't be installed flat using a D-box at different heights, but you're going to see some kind of change in grade where a change to that grade was made when the system was installed. Almost certainly you're going to see a change in that native grade that's going to clue you in. Not always. I suppose it is possible that there could be no evidence, but nine times out of 10, 95 times out of 100, you're going to see some indication of a change in slope where that final treatment area was put in. Change in grasses, again, everybody says lush, but sometimes it's dry. I've found systems multiple times because I've noticed a dry area versus a wet area. In the winter in our area, melted snow can clue you in, so that if the septic tank is high enough, the warm water coming into the tank keeps the soil above it warm enough that the snow will melt off. If the tank is shallow, probably not going to happen in your area. I try to walk the area from more than one angle. A lot of times with trench systems, you can see, so if you used to have a native grade that was perfectly flat, you'll see these little scallops over each trench where the trenches were set and then filled, but then that fill material and that disturbed soil has settled a few inches. So if you look across it from one angle, it looks really flat, but if you turn and you look at it from a different angle, sometimes you can see those little settled trenches at uniform spacing, and you're like, oh, okay, there it is. I can't tell you how many times I've gone to a site, found that uniform space settling, put the probe in, and hit gravel immediately. And don't forget to ask the homeowner. That's why I try to ask the homeowner immediately what they know. Sometimes they know more than anybody else. In fact, often the homeowner or the property owner or the contact, the site contact, they often know more than anybody else, and they might just say, hey, it's right there. This is a site I was on. I got a picture. It's very hard to, right? It's two-dimensional, right? Photograph is 2D versus 3D, so it's hard to translate. But um, I spent a long time looking for this drain field way off in the background here. There's a flat area that's further in the back of this picture that's like really obvious and open and flat. And I spent a long time over there looking for it and never did find a drain field over there. And I was walking back and forth across this property, and I was right where I'm standing taking this picture. I turned around and I looked from this perspective, and all of a sudden I noticed there's a spot right here that looks like the corner of a flat grade where they had flattened off the top of this new drain field and graded it, and it again, it changed the topography just enough, and I'm going to lay it out for you so you can see it. It's right there, right on that corner. There's like a 90-degree corner that happens there. Yeah, I don't know if y'all can see that, but right there, there's a spot where the grade changes. And it's almost, you can almost tell because the leaves have blown off of it and they've blown downhill on the back. There's that pile of leaves. So the wind has blown them off this flat spot and they've blown down into that lower spot where there's a little change in the grade. And of course, as soon as I noticed that, I put my probe in the area and immediately hit the trenches. In this case, the trenches happened to go up underneath this structure. So this is a case where they built a structure on top of the final treatment area. System went in, they added this structure later, and they built it right over the top of the end of that drain field. But this is a dead giveaway. We got a very shallow septic tank, so all the grass has died over the septic tank, and apparently this dog is a big fan of that. Dry dead grass or vice versa, lush grass over a septic tank might be a problem. We might have a leak. Spotty grass, again, if somebody has an existing lawn of a certain type that was installed well, especially if it's a really nice lawn, and then you come in and you replace the system later and you dig it out and you put a different type of grass seed in there or a different type of cover, sometimes you can tell there's some type of different cover there that doesn't look like the rest of the area. I find this all the time. I can't tell you how many times I've found a tank by stepping in a divot, walk in the yard trying to find something, and I take a step and it's a few inches lower than everything around it because the lid has been dug up there repeatedly and the soil has sort of just settled and been moved out of the area. I find tank lids that way often. Um, homemade risers, whoops. Homemade risers are another one too that, like in our area, people will build like a almost like a wooden deck structure over as like a riser. People love to do that. I don't know why. It makes a mess, but they do. In this case, we have, again, this is kind of a winter picture. So the grass is sort of dead and laying flat because it's been dormant all winter. And this is in the spring. So the snow has just melted off. All the grass has been matted and packed down from the weight of the snow on top of it. And in this case, we found this happens to be this was a dry well or a seepage pit. And we found it because there was, in this case, right where Ethan's left foot, so the right side of the picture, is in a divot that had been dug up several times because this dry well had an access port on the top. that had been dug up multiple times over the years, and there was a depression there. So when the lawnmower goes over it, it cut the grass at the same height as everything else, but because the soil was lower there, the grass was actually longer than the surrounding grass, and that longer grass like fell over and matted more obviously. There was a spot there with like thicker, more matted grass, and it was because of that divot, and it was a dead giveaway that helped us find it right there. All right, let's go inside the structure. Let's find the main outlet line. Let's see what time is it anyways. How fast do I need to go here? Better speed up. Sorry, guys.
Are you going? You're going okay. That's fine.
Okay, all right.
Yeah.
Like speed talking, and then you won't understand what I'm saying. Okay, so let's take a look inside the structure. Again, a lot of times I'll try to do this first thing. Number one, because my shoes and boots tend to be cleaner if I do the inside work first, go inside before I make a mess. So I tend to start inside anyways, but go inside. Like I said, in our area, a lot of times we can go into the basement. I'm guessing basements probably aren't as common in your area, but I don't know. Um, so if if you have a dug basement that's subsurface and you can see that pipe leaving the wall, it's a dead giveaway. That's awesome. If you have a plumbing stack or a sewer stack that goes out sub floor, like under a finished floor, or out of a wall, a finished wall that's covered, it might be a lot harder to see. But if you can find it and you can see it, that's great. It'll at least help clue you in a little bit. So we're going to measure to something that we can see outside. So if I find something inside the house that's cluing me in, I try to take a measurement to something I can see outside so that I can replicate that. In our area, like a basement window is common. In your area, it might be something else, but a window is good because you can look out the window. You can see what's inside. You can look out the window and reference that window with your measurement. I don't know if y'all have ever run into this, but I've run into notes like almost like a treasure map, where somebody, you've got the outlet pipe from the house, and somebody has literally written on the pipe or on the wall next to it with a permanent marker or Sharpie or crayon or whatever. Sometimes there will be a note there. I've even seen people draw a map. I've had a map drawn on the wall next to the outlet pipe before. Um, hey, if it's there, great, use it. You gotta you gotta know somebody 40, 50 years ago was thinking ahead when they did that. And good on them for doing that because it saves me a lot of work. So this is what I'm talking about. Again, I don't know if this is common or if you all have ever seen anything like this. So maybe you know what I'm talking about, maybe you don't. This is a 4-inch cast iron leaving the sidewall of a basement. In the top right corner there is that basement window. We can take a measurement down from grade, and we can take a measurement over from the window, and then I can replicate that measurement when I'm outside, and it saves me a lot of guessing. So again, anything we can do to be objective, measure, is great. Let's see. That's about all I got on that. So any Warcraft fans in here? I ask this all the time. Apparently there's not enough nerds in the septic industry because nobody ever plays Warcraft when I give this presentation. I feel like I'm the only nerd in the whole septic industry. Um, Probing tips. Here we go. So now we're actually on the site. We're doing some probing. In this picture, you can actually see my orange marking paint. This is a trench that actually goes under both a driveway and a building. Amazing. When we're probing, try to make clean pushes. Again, if you're jerking the probe around, you can't feel anything. Again, whether that's a chamber unit, a pipe, a gas line, an electric line, or gravel that you're looking for that gravel feedback on the probe. Um, if you can make one good clean push, you can feel and hear that feedback better. Once you hit something solid, I try to just drop my weight on the probe. If you're pushing the probe down and you feel resistance and you think you might be on some gravel, just drop your weight on it. And usually when you do that, you can hear it crunch. The probe will sink in into that gravel or into that stone an inch or so, and you can hear and you can feel it crunch and give. And it sounds very different than anything else. Very different than a concrete tank. It's very different than the surrounding soil. It just, I don't know what to say other than it feels and it sounds crunchy. If you don't know what I'm talking about, take your probe and go over to a gravel driveway or a gravel road or something and push the probe into that gravel, and you can feel and you can hear it crunch. Again, if your probe bounces, learn from my mistake. Don't poke holes in the water line or the gas line, even worse. Don't forget your marking paint and your flags. Probing tips for tanks. So obviously with a tank, we're gonna have a lot more like solid feedback. And again, if you don't know what I'm talking about, take your probe over to a gravel or a concrete driveway or an asphalt driveway or surface, don't damage the surface, but put that probe on that surface and you can feel it bounces like a bouncy ball, right? Because we've got a solid steel probe and we've got a solid concrete. When it hits, there's no give at all. I mean, it'll just bounce right into your hands because all that force is coming back to you. So the tank, we're obviously going to have that really solid, unforgiving hit. If it's a plastic or fiberglass tank, that might be a little bit different. So be careful that you're not just banging on it, put your tank or put your probe right through a plastic tank. Once you get a hit, probe nearby. We should have multiple hits at the same depth. If you get a hit that you think is a tank and you probe 4 inches one way and you go another foot deeper, go the other way. If it goes another foot deeper, it's probably not a tank, right? Your septic tank's going to be, you know, 8 by 5, 10 by 5 feet in size, depending on the tank, obviously. But if you're getting hits at different depths, it's probably not a tank. Your top of your tanks better be flat. It should be. So more hits in an area this tank size. If you're probing along and you fall off and all of a sudden your probe drops deeper, you can mark that as the edge of the tank if you're pretty confident that you're on the tank. Then you can use those marks to start laying out the tank. So we use flags or marking paint to lay out. So we get same hit, same hit, same hit, deeper hit. That's so we know we went off the edge of the tank. So we mark those edges, find the long side and the short side. We can kind of figure out, is the tank pointing square? Is it off kilter? It gives us some clues. Not all tanks are set square to the house. If the tank is on an angle, so if your house is, it's going to be really hard for me to demonstrate this on the screen, but if your house is here and your tank is often dead perpendicular to it, a lot of times they'll set the tank, your outlet line is coming out the house going this way. Your tank is usually going to be straight in line with it because as installers and contractors, I don't know how many of you all are on-site installers, but installers don't tend to do anything that takes more time, effort, or money than is absolutely necessary. And that's not a dig at the installers. They just want to be efficient and get the job done. So if they can run the pipe straight and they can set the tank straight, they're probably going to do it. There's no reason for them to start making weird angles. They're probably not going to do it. So if we come out of the house and we hit that tank and the tank is on an angle, again, at least in my area, a lot of times that final treatment area tends to run off in the same angle as the tank. Not always, but often. So if you find that tank on an angle, it might be pointing you towards the final treatment area. Where do we start if we don't know the tank location? So again, installers are usually going to take the quickest, easiest route to install. They're not going to do weird stuff unless they have to. Your particular location will probably specify minimum distances from structures to a tank. So in our area, often that's 10 feet. We start about 10 foot away from the house, in line with that main line if we know where it is. And we can probe every couple of feet until we hit the tank. That works 80–90% of the time. Keep an eye out as you're working for signs of tanks and try not to probe a gas line. Didn't find the tank on the first pass? Take a second and think about what you might have missed. Move left or right of your probe line and try again. You might run into it. If you're really struggling, start leaving a marking flag in each of your holes. It'll save you from probing back over areas that you've already probed. If that doesn't work, grab your flushable locator or your sonde. So here we've got little blue dots that represent our probe holes. We missed the tank there, but maybe if we try another line, we run into it over there, right? We are now looking for the drain field. So we found the tank. We're gonna look for the drain field. Probe out the end of the tank and start probing about 2 foot off the end of the tank. I've seen final treatment areas installed just really like almost butting up to the tank. They really shouldn't be installed quite that close, but I've seen it happen. So if you assume the drain field is going to be further away, you might miss it. Probe every foot or foot and a half in a straight line away from the tank. Most modern trench systems call for a 3-foot wide trench. Older systems or systems that were unpermitted may not have a 3-foot wide trench. I've found just 4-inch pipe straight in the soil before, which you just got to get lucky you happen to hit it. I've found just 4-inch in soil with no gravel at all. Obviously, that's not an acceptable system, but it does happen. Run a tape and probe every foot, or use a boot spacing. Just be consistent, and then listen and feel for that gravel. In our area, especially historically, a D-box is very uncommon. Usually it's just septic with an outlet line straight to a header, what we call a header or a bridle, where it then splits to the laterals. But if you can find a D-box out there, great. That's going to save you a lot of time, obviously. Yeah. So here's our probe spacing. If we space our probes too far apart and we got a narrow trench, we might just miss that trench altogether. With a modern 3-foot trench, we're probably going to hit it. That's, 3 foot is a decent amount of room. You're probably going to hit it. But with a more narrow trench or something that was installed strangely, you might just miss it. All right, we made it across the whole yard and didn't find anything. Go back to the center line of the tank, walk out a reasonable distance. And when I say that, I mean just kind of use your judgment, look at the area, think about, your system's probably going to be at least 20 by 50 or 30 by 40. Your system's going to be pretty decent size. And that's feet, I guess. Y'all probably use meters, but either way, they're not small, right? Your drain fields aren't going to be tiny. Start going. So we probed this way last time. Go the other direction, because if we've only got one header and one footer on a system usually, but typically we're going to have a half a dozen, 3, 4, 5, 6 laterals running the other way. So if you go perpendicular to your first pass, you might have a better chance at finding the laterals. There's just more of them. So again, here's our tank, and we probed away from the tank in blue, didn't hit anything. Make a pass going perpendicular to that next time. So think about different shapes. They're not always this common shape. This is a common shape. This white drain field layout is common in our area, not always common in other areas. Again, like I said, you've got that header and that footer. There's only 2 of them, but you got 4 laterals. So if you go looking for the laterals, you might have a better shot at running into them than you would looking for the header or the footer. Think outside the box. It could be something that's totally unusual. So here we've got an asymmetrical drain field layout. It's possible you've got something like this. If you make this first probe hit in green and you assume that it's a rectangle, you might mislead yourself. So, if you're confused, start thinking outside the box. Always room for new surprises. This was one of the very first systems I ever inspected. The tank was on one side of the driveway. Outlet line went under the driveway to a D box. And then that D box went off into these 2 triangles, like a bow tie shape almost. I don't know why they did it. Not a clue. It was even permitted that way. Fortunately, I had the permit. It was installed correctly to the permit. I don't know why they did it, but it was this weird bow tie shape. So you might run into something. You never know. You run into something weird. People do weird stuff, especially around here. People do really weird stuff. Don't let a parallel layout fool you. So we got this like tuning fork type setup called parallel. So you got that outlet line from the tank is essentially the header. And this is really, really hard to tell, but up here in Michigan, we have leaves that have fallen off and they've gotten wet. And the way that I actually found this drain field, I was able to see the wet leaves had settled down into these little scallops. Again, we talked earlier about how the trenches can settle a little. The wet leaves had actually settled. You can see this like clump of leaves right here. That spot is actually a few inches lower than the surrounding yard. And that kind of clued me in. I saw a couple of these low spots with wet leaves in them, stuck the probe in there, and immediately hit my trenches. Trust me, it doesn't always go that well. I'm just sharing with you all the stuff that I do that works really well, so y'all think I'm super good at finding stuff, but it doesn't go that well all the time. usually out there just probing around like an idiot, sticking the probe in the ground for an hour trying to figure out where stuff is. In this case, you can see disturbed soil. Somebody had already dug up this tank. That clued me in. I was looking for the drain field in this open area. You've seen this picture before from a different angle. I was looking for the drain field in this open area that's close. It wasn't there. I deceived myself. It was actually underneath this garage. They had built this garage right over the top of that drain field, and I wasted a bunch of time looking for it. This is an example of how they had oriented, how I talked about a lot of times that, at least in our area, people tend to point that tank outlet at where the drain field is. And in this case, they totally did exactly that. They pointed that tank directly at that drain field. System components in this picture, other than my coffee mug in the bottom left, which usually isn't a system component, except on the days when I accidentally drop it in the tank, along with my cell phone and whatever else goes in the tank, because that's just how it goes. We got a homemade wooden riser here. And then a few feet over, we've got what I thought was a plastic tank. So from here, what do you think might be happening with this system? I'll tell you what I thought was happening with the system was I thought the system was going into this cornfield over here. That's what that is. That's a cornfield in the distance. Remember, like I said, a lot of times in our area, they used to run drainage tile through the cornfields. People used to connect their septic system to the drainage tile in the fields, and then it would run off to the creek. So that's kind of what I figured was happening here. It was not. It was, in fact, you can see surfacing right here. I walked out into the field and I found this nasty pile of surfacing septage because they had installed non-permitted infiltrator chambers here, chamber units, and they were blowing out into the farm field over here, making a mess. This is a river right on the left side. This is the Grand River in Michigan, obviously in the wintertime. And we have a non-permitted system here. This obviously should not have a final treatment area that close to the river. That on the left side falls off immediately. It's very steep, about 15 feet down to the river. There's not nearly enough room between that final treatment area and the surface water for proper treatment. Sadly, stuff like that happens. But there's a tank right here that we had dug up. I had to get it pumped out, and the drain field was right here. I mean, it ran right up the edge of that driveway. Obviously not a good spot for a final treatment area. Sadly, that's what we found. So not great. If I was on this site, if I hadn't had that tank lid dug up, I would have been struggling to figure out where this drain field is. I would have never looked for a tank and a drain field on that side of the driveway wedged in there. I would have been looking somewhere else in the yard under the driveway. I mean, if the homeowner hadn't told us right where this tank was, I would have never found it. Any clue on this one? There's a tank here. We're almost done. I'll wrap this up here in just a sec. There's a tank here. In this case, it's under this stall mat. Under this, there's a rubber mat next to in front of that shed. People like to put stuff over their septic tanks. Just stuff, whatever it is. That's where the tank was. I finally found the tank. Finally found it in there. I don't know if y'all can see this on your screen. I've talked about this a couple times, but in our area, when the leaves fall and start blowing around in the autumn, they tend to settle into low spots. You can see on the left side of the screen, there's a couple of evenly spaced spots where there's some leaves built up. Those are the trenches. If I remove that, you can kind of see it in the lawn, almost see that divot, those scallops where the settling has occurred from these trench systems. My probe, I guess I should have taken my probe out. That's kind of cheating because my probe's in the picture, like right in the middle of that trench. But anyways, there's those trenches. They're definitely not always this obvious. And that is the end of my slide. So I will stop boring y'all to death. And if anybody has questions, feel free to fire them off at me. I'm sure you can get my contact info from anybody. Valerie's got my contact info and stuff. So anyways, thank you for your time. And if anybody has questions, feel free to shoot them my way.
Yeah, thank you, Casey. That was quite a bit of information and rather comprehensive. I think very often we don't. I mean, in our parts, we do a lot of septic tanks. Um, except for in some of the inner city areas, we have central sewage and collection systems. But pretty much in many of the islands, it's all septic tank. So I'm sure that would find some interest with some of our participants here today who may have some questions for you.
Well,
So please go ahead.
when one of you puts together, do the same presentation, but from your part of the world, because I want to see what happens down there.
Yeah, it would be interesting.
Yeah, it would be fun.
Yeah. Anyone, please? The floor is open. While we await some comments
Hi.
and so on. Yeah, go ahead.
Yeah, sorry about that. Timothy, I
That's all
guess,
right, Tim.
yeah, professional operator out of Trinidad and Tobago. Very, very interesting lecture today. In fact, I've found some weird stuff in my line of work looking for some of these tanks. One time we were removing, we couldn't find the tank and we were actually removing some toilet bowls in a school and the whole line of toilet bowls fell down into the tank. So the actual toilet bowls were built above the septic tank.
That
So,
is crazy.
so trying to find these things, is really a challenge at times. I'm thankful for the advice of the Google Earth Pro. I think you could do something like this when you complete an installation and keep it as a reference. You could take like a snapshot of it and keep it as a reference. So in changes in the future, you could always go back to that.
Sure.
Um,
Yeah. And you
yeah.
might even be able to find, I wonder, especially like for something newer, you might even be able to, if you could go back far enough, see an area that was not cleared and then go, 10 years in the future, see what has changed. You might even be able to get some clues that way. That is insane. I can't believe that whole row just fell right into the tank.
Yeah, yeah. This was actually this was in a primary school, huh? In a what do you call for smaller children, and that was amazing. But thankfully, no one was hurt. Just another question here. In terms of the septic tanks themselves, is it that only concrete, because in Trinidad and Tobago and other islands, I suppose we use a lot of the fiberglass or plastic septic tanks. So I just want to know if you all would allow that, or what's the situation with that?
Yeah.
Because in many cases it wouldn't be a normal flat surface.
Sure. Yeah, for sure. Yeah, the difference between your concrete and the I guess manufactured isn't the right word because concrete's manufactured too, but the plastic or the poly tanks versus concrete, right? Your concrete's just dead flat. Plastic, in my experience, it even with the tanks, it's more bouncy. There's nothing else in the soil that's bouncy. It just nothing bounces in native soil. Every time I've hit either a plastic tank or a chamber unit, there's some give to it, some springiness. And if you're using a round nose probe like mine, I mean, mine gets so dull that it's almost flat half the time. And you shouldn't go straight through it. You should be able to put a little bit of force into it without, ruining whatever you're probing into. Obviously, do so carefully, but in my experience, everything that I've ever hit that's plastic in the ground, it always has some give to it. There's just a bounciness there that's not natural.
Yes. Thank you.
Sure, yeah.
Any other questions, please? Or comments, feel free. Well,
Yeah,
I think, yeah, go
so,
ahead, Daryl.
sorry about that, Mr. Ja. Hi,
No.
afternoon, everybody. Casey, okay, Daryl from Trinidad and Tobago here. I joined a few minutes late. I just want to know if you could just explain exactly the structure, how the final treatment area across there is made. I'm not sure if you went through it, and sorry if I have you repeating yourself.
Oh, no, you're fine. So most of what we talked about is either a trench or a bed system, which would be like pipe and stone, people call it, where you're with a trench system. I don't know how, stop me if I'm being insultingly over explaining things, but if you were to look at it from if you could cut a side profile down into the soil, you'd have a trench here and then native soil and then a trench here. And basically you're excavating trenches, you're putting in 6 inches of stone, you're laying down a pipe, filling that pipe with stone, and then adding another 4 inches of stone over the top of it. So if you were to carve away and look at the system from the side, from down in the soil, you basically have a subsurface rectangle or a square of gravel with a pipe right in the center. And one of the things I've run into that people have with this weird misconception is not not usually industry professionals, but a lot of times customers or people that aren't familiar will say like, "Oh, what are you looking for? You're trying to hit the pipe?" And I'm like, "No, if I'm hitting the pipe, something's very wrong. The pipe should not just be buried in soil. It should be surrounded by aggregate. Some of the modern systems, you might have oh geez, what are they called? What are the synthetic aggregate? Basically, like some of the advanced alternative systems are using synthetic aggregate or not quick chambers. Geez, what am I thinking of? They sell them in 10-foot sticks that are it's a 4-inch pipe with basically packing peanuts around it. That's a like a pre-constructed trench system basically, and you just throw that in the ground. If you're probing that, you're probably going to go right through it. You're going to hit it. They feel very differently. Hopefully, you've got records for that, but with a trench system, you got that. With a bed system, in our area, anywhere from 800 square foot to 1600 square foot is common. So you're usually looking at like a 30 by 50 or so, and that's feet, but you can extrapolate. And you would excavate that whole rectangle from the top down, lay a bed of gravel, lay your network of pipes, cover them all with gravel, and then backfill the whole thing, which is why we mostly talk about trenches in this presentation, because if you've got a 30 by 50 foot surface that's all gravel underground, it's pretty easy to accidentally probe that. I mean, you're going to hit it. It's enormous. It's huge. So bed systems are great if you run into a bed system because they're really easy to hit.
Okay. All right. Thanks a lot.
Yeah, sure.
Any others?
Yeah, one more
Yeah.
question, Mr. Chair.
Owen, yes,
Yeah,
go ahead. Go ahead.
yes. Hi, Casey. Good. It was a mouthful, the presentation. Couple of questions tied into one. I know sometimes you go at sites, and sometimes the customer, they might be a new homeowner also, and it happens sometimes where they don't know what kind of wastewater system they have. You might have I've encountered in the tri-state area, they mostly have sewer lines and the clay pipes, or it might be cast iron going straight into the city. But then you might have clay pipes, probably for about 10 yards or 10 feet, and then it goes into a septic tank. Have you ever encountered times where you had to locate the sewer lines?
Yeah. So yeah, we're mostly this presentation focuses on-site systems, but yes, we do. So my company does work on sewer lines as well, and we're in an area where some of the original structures in some of the older cities, like a lot of the Michigan cities, are a lot of the infrastructure is kind of like early industrial, even back to like I mean, some of the farmhouses around here are like 1860 construction. Um, and they're old, like the foundations are made out of field stone, just stacked stone from the fields from like literally original like settlers from the area. Obviously not, not native, but colonized. And so some of those structures are very old, and some of the um, urban structures that would be connected to sewer are equally as old. I mean, at the time that some of those structures were built, they were some of the first structures in the area. I mean, and then a lot of times those were connected to an on-site system and then got connected to sewer. When sewer came through and became available, they got connected. So now, and we run into this several times every year, if you live in an area that now has sewer, but you still have a septic system. We have people that have city provided city provided water, municipal water, but they're still on a septic system because their septic system's from 1952 and it's still working. But it's just now failing and now they need to replace it. So now we're coming in and they're saying, hey, we need to replace our septic system. They can't get a permit to replace it. If there's sewer within 200 feet, you have to hook up to the sewer. And that is pretty common around here still, with very, very old, super old farmhouses that used to be in the middle of nowhere that are now, the cities have just grown out and encompassed, and sewer has run out to areas that didn't have sewer before. So we do run into that. And we also run into original sewer connections that were either like terracotta, clay, or cast iron that have to be replaced. That does happen once in a while. My company does a lot more with onsite than we do with sewer connections, but we do deal with some of that. And we get the whole range of stuff like that for sure.
Yeah,
Okay,
some
great.
good questions. Any others? I was going to ask, what are some of the typical challenges you find is doing the type of maintenance on those, particularly with I think the seepage pits.
Oh geez, seepage pits. My preference on seepage pits is to tell the homeowner to please replace it and test their water and stop poisoning themselves. Number one, but number two, um,
Mhm.
seepage pits are so uncommon in my area. It's Michigan, as far as North America and the US in particular, Michigan does not have a state level uniform sanitary code. It is still up to the counties, which if you're not familiar with the counties, I have no idea if this is the way it's laid out in your neck of the woods, but here our counties are, I don't know, maybe 50 miles square. So we have a patchwork of counties that all have local jurisdiction over their health codes. And each of those counties, I don't know how many counties we have, 50 something, only 11 of those counties actually have a requirement for septic inspection at all. The other ones just don't have a requirement. And all of them have conflicting codes. So you could be in my county that I work in, and they'll say, yes, you can put a seepage pit in here. And you go to the county that literally shares a border with us in the same state, and they say, no, you can't put a seepage pit there. Or they'll say, if you got a 3-bedroom house in this county, you can do a 1,000-gallon tank. If you got a 3-bedroom house 20 miles away in the other county, you got to do a 2,000-gallon tank, because they'll disagree with each other. So one of the biggest challenges we have is poor information. Our counties, our county health departments that control this stuff are chronically underfunded. They're publicly funded, they're government institutions, but they're still chronically underfunded. They disagree with each other. There's no agreement at the state level. So that leads to misinformation, not misinformation, but just a lot of conflicting information. And there's also, weirdly enough, there's kind of some of the health departments are more interested in doing the right thing than other ones. There are some of the health departments where people have been appointed to positions at the health department and they just want to ride out, their next 5 years to retirement, and they don't want to lift a finger or change anything. And so they're unwilling to do anything. And there's other health departments that are much more progressive and have more modern codes and have stricter requirements. In our area, there's only one county I know of that still allows a seepage pit or a cesspool. That's Jackson County to the south of me. They are the wild, wild west. If they permit anything at all, they barely pay attention to it. They'll let just about anything fly. And as a company, I've had to tell people, I'm not going to install that system for you. And they're like, well, it's permitted. I'm like, yes, it's permitted, but it's permitted wrong, and I'm not going to do it. I've had to walk away from jobs because the lack of knowledge and education and the lack of quality in some of the sanitary codes is leading to people being allowed to install systems that shouldn't be going in the ground. And we will walk away from those as a company. I'll just say, hey, look, it's not worth the money. Let somebody else install it. I'm not willing to put my name on something that's being done, basically backwards. So that's some of the challenge we run into for sure.
Yeah. I think not uncommon. I think sometimes, some of the issues that we face or challenges is just different territories, different locations, but pretty similar across the jurisdictions. Another one I would ask is about in terms of the septic tanks, well, the collection points. You do a lot of maintenance as well. So what are some of the issues or how often would you be doing the maintenance on these? Or do you get, well, you already said that there's not any regulation per se in some areas, but in terms of having to remove sludge and that sort of thing, how often would you have to do that and that's initiated by the householders, or the owners of the properties.
Yes, and unfortunately, it's usually initiated once there's a problem. People tend to forget about their on-site systems until all of a sudden there's poop in the basement, right? As soon as the poop comes back in the house, then all of a sudden everybody wants to wants to catch up on their maintenance. And I'm like, well, it's a little too late. People will recommend every 3 to 5 years, but it obviously depends on the size of the tank and the number of people in the house and its use load. A lot of people in our area are pretty good about maintaining their system and getting it pumped out, usually on a, maybe a 3 to 8 year basis on an average, but it can be, wildly variable. There's still some weird old myths out there where people think that, if you use additives, then you never have to pump your septic tank. If you put spoiled milk down the drain, then you never have to pump your septic tank. I kid you not, there used to be a guy ages ago that worked for my parents as a septic pumper. I remember it very well. And he would literally tell people to throw a dead raccoon in the septic tank to add bacteria to the septic tank. So there's some weird stuff out there. Obviously, we don't tell anybody that anymore. You say that and you work for me and you're not going to work for me for very long. But maintenance on concrete tanks, hydrogen sulfide corrosion is a big problem with concrete tanks. If you got a concrete tank that's been in the ground for more than 20 years, sometimes less than that, anything above waterline is going to be susceptible to hydrogen sulfide. So H2S is an off gas from wastewater. I'm sure a lot of you are very familiar with that. Some of you probably more than me. I'm not a chemistry guy, but basically you get your H2S off gassing in the tank, and then everything above waterline, as that hydrogen sulfide mixes with the condensation on the walls of the tank, it forms a mild sulfuric acid by bonding with the hydrogen and oxygen and whatever, chemistry, right? Math and magic. That forms a weak acid and it starts eating away at the concrete. And after 30 years on the ground, when we pop that outlet lid, usually around the penetration, the inlet and the outlet penetration, that tends to be where that concrete, you can take a tool or even your gloved finger, you can wipe off the concrete. It comes off it's almost like wet chalk. Like if you got a piece of white chalk and you just got it wet and it just turns into like mush. The concrete, you pull a concrete lid and you look at the bottom of the concrete lid and it's covered in white mush, and that is the concrete that is just turned into wet, soggy, corroded goop, and there's nothing left of it. And that's usually due to, corrosion above the water line. You pump that tank down and you go below the water line, anything below water line looks like the day it was put in. I mean, it looks perfect. Everything from the water line up is just destroyed. So that's a big one. The other maintenance problem obviously is cast iron. And other than that, with concrete tanks, which is predominant in our area, it's not a ton. Some of the older poly tanks that got installed improperly, we run into issues with them trying to be buoyant, pop out of the ground. Obviously, your bed systems and your trench systems are a gravity fed system and they're passive. They tend to be older. So usually it's just a matter of people not having maintained their system well enough over the years. And sometimes those trench and bed systems have begun to see the end of their life as they fill up with sludge and scum and biomat, or as material fills in the void space of that aggregate. Not a lot you can do about that. Some people try to do repair work on drain fields. There's some disagreement in the industry I'm sure you've heard of or been exposed to. There's some wide disagreement in the industry about terra lifting or fracking or different types of drain field restoration attempts. Certain companies have different flavors of that they might attempt to perform. But we get into maintenance on more advanced systems where you're not, not a passive system. We see ATUs in this area, packaged ATUs for on-site systems. I see that often, aerobic treatment units. And there's no requirement here at all to maintain them. Some states require that you maintain, you have someone come and look at your ATU or your advanced system every year. Here, there's no requirement for that. So what happens is 5 years after it's installed, it's never been maintained. The ATU buzzer alarm starts going off. The homeowner takes a hammer and hits it until it stops going off. And then they ignore the system and it all blows up. That's usually how advanced systems are treated in my neck of the woods.
All right, Casey, that's a lot. That's I mean, I've been chuckling because there are so many things that you've said, and we can identify with many of that. Like throwing some of the additives down the drain pipe and hoping that it will add more bacteria and so on. So yeah, so that sounds familiar, I'm sure, to a lot of our participants who are on board with us
That's
this
awesome.
afternoon. Yeah, so we'd like to thank you very much for sharing those experiences with us.
Very
And no
welcome.
doubt,
Thanks for having me.
one of these days we can reciprocate with some of our own challenges.
Yeah,
But it's good that we can see the similarities across
when
the.
that presentation comes up, you better let me know because I definitely want to. I got to see some of the pictures and hear some of the stories.
Sure. In
Sounds
fact,
great.
what the photo in the background is as we working with, it's called Carib Sand. It's a project that we work a constructed wetland treatment system. It's been used quite widespread in the French islands of Martinique and Guadeloupe, and now we have a pilot project ongoing in Dominica and St. Lucia. So we're just beginning to roll out. But this is what the setting is like. So you're going to have, it's called planted filters. So you would have some those heliconia plants are using in the system to help with the aeration. But it's quite a good nature-based system, um, nature-based solution for wastewater treatment. So we are going to commence that pilot in these two islands shortly.
That's
Um,
awesome. Does that
uh,
system does that have an outfall or is it all captive there?
no, well, there's some collection points, and then the water is the wastewater goes through the filtration. There are various levels of aggregate, and of course the the plants help to with the soil aeration, and so that you do not have the sludge, creating blockages for the filtration of the water system. And it would be tested before it finally goes out into the natural waterways.
It does. So it does eventually leave that and go out to. Oh,
Yes,
that's really
yes,
cool. That's awesome.
yeah. So I will share with you sometime. I've got your email. I'll send you some more information about it.
That'd be
Okay.
great. Yeah, and feel free to share my email to anybody else in here. And if any of you all run into weird stuff while you're doing inspections, one of my favorite things to do is to share pictures of weird things in inspections. So don't hesitate to email me weird stuff. I'll get a chuckle out of it. I guarantee it.
Thank you.
Thanks,
And I would
everybody.
like to thank everyone for joining us. This is CAWASA's Wednesday webinar. I'm Ignatius Jean, your host. And our special guest today was Mr. Casey Fiddler. And we'd like to thank Operators Without Borders for finding Mr. Fiddler for us. And have a good evening, everyone. And see you next week.
Bye,
Bye.
everybody.
Okay.